Alright, cool. I think we're ready. Let's see. Let's get started with the stream and see what's up. Hmm. Hmm. Unloved by generation of soldiers, blah blah blah. Home build pickups, how underage teens skirt the law to drive in Sweden. Hmm. Hunting tech debt via organization charts. Okay, this could be interesting actually. Yeah, actually, let's see what this is. Knowing where to look for problems by figuring out who reports up to whom. Interesting. With a very simple party trick, we're going to mind. Key details of what their problems were going to be. All I knew was the name and title of the person we were meeting. Huh. Wow. Nowadays, as I talk through their legacy modernization struggles, the first piece of advice is to look at their org chart. Too many stones to flip over, but the types of problems organizations have are heavily influenced by their incentive structure, and easy ways to figure out their incentive structure by looking at their org chart. Okay. Yeah, that makes sense. On particularly old systems, you might even end up doing an overview of how the org chart has changed over time, breaking things out into sub-layers of problems as incentives have shifted. I go into a lot more detail about the nature of incentives. This isn't about money. This is about how people feel seen. Sure. How do incentives change behavior? How do people get promoted here? The true operations of systems are determined by the day-to-day decisions of individuals on the ground. Yes. Those people are born going to prioritize the work that helps them get ahead, and they fuck the technical debt. Yeah. But he hasn't really said anything, you know? He hasn't said anything here just yet, so... So I'm curious, like, okay, he says to look at the organization chart, but then how exactly does that help? Like what? Give me an example here. Although we're accustomed to legacy projects coming from large organizations, all organizations start off as small. Yep. Too small for structure. Flat was background of the CEO. If they have a free hour, are they pushing cold or making sales calls? Sure. Engineering first organizations like Google, Facebook, these organizations where engineering trumps everything else. If you're not engineering, your pathway to promotion is limited. Correct. What kind of problems will you find? There are many paths to center in both life and engineering. When engineering runs the show, you tend to find multiple paths. Implementations of the same thing, sure. Fall out of sync, systems get rebuilt until gap and feature parity is too high, the abstraction layers are piled up. Engineers love meta work, or the engineering work that is supposed to make other engineering work easier, faster, more secure. Mid-career engineers aspire to deploy features. Senior engineers aspire to deploy massive frameworks. Yeah, it's kind of like this obsession with over-abstraction. And it does definitely happen. Because, like, the incentive structure is like, how do I generate impact? Oh, let me create this interface of an interface that other people can use. And the easiest way to do that is just to create some weird abstraction, regardless of the use case. So with these organizations, you want to look for problems associated with the unnecessary complexity. Yes. The good news is that the practice must take on to survive complex systems are good practices regardless. Mature on-call, blah, blah, blah. Bad news is that beautiful tech is unrelatable to profit. Yes, correct. This incentive is actually pretty interesting. The bad news is that beautiful tech is unrelated to profitable tech. That's correct. It doesn't matter how good of a code that you write if no one uses it or it doesn't bring in money. It's just a means to an end. If the business isn't making enough money to support the level of complex engineering running, then engineering can't staff teams at levels to maintain the healthy work-life balance. Okay, that makes sense because you're gonna drive people, away, or you're gonna overload them. A complexity should be growing to support business growth, not the other way around. Yeah. Good practice around managing complexity breaks down and institutionalizes laws as people burn out and quit. Okay. This is actually kind of describes a lot of what is happening with those hire and fire cultures. Essentially, what are a good practice you may have, trying to break down the, the good practices and guard the code base, you lose them when you just burn through people. In this case, figure out which teams tend to lose staffing battles and assume low quality value engineering work is not getting done. This means things like updating dependencies, migrating security reports, blah, blah, blah. But what work is devalued is obviously part of the company culture. Look at what people get rewarded for doing, not their marketing copy. Don't assume that security companies prioritize resolving vulnerabilities any more than any other company, because not all of them do. Yeah. I would say the staffing battles. If you look at areas of high churn, then assume the low value engineering work is not getting done. No, I would assume that they're losing staffing battles and they keep getting picked apart. That most likely there is low quality shit getting done in that area, so it's not great. Engineering product have fundamentally different goals. Yes, when one reports up to the one parent other parent group, it just ends up suffocating the subgroups. Yes, we've seen this very very often where product wants something to look some way, but then engineering says no, you'll blow up the code base by doing this. Oftentimes, people claim that all their products people are superior technical do not have this problem. That's BS. The problem engineering experiences under products are all about incentives, not technical correctness. Yeah, it's because you want to create a product that does X, but then you'll cannibalize your engineering in order to do so. But the product people don't care; they just want it done, right? So that's what this means. The incentive, if it's a ship out shit, it's gonna break. It's gonna basically cannibalize your own quality in order to get it done. Engineering wins by producing some beautiful scalable systems. In pursuing that, they sometimes build too complex too quickly. Correct. Product, on the other hand, wins by putting new stuff in front of customers as often as possible. In doing that, well, they sometimes, well, cut corners. Yep. You need a prototype, minimum viable product, but then you incur a lot of technical debt in order to do so. When building prototypes, engineers skip on a lot of scaffolding. Yep, it feels ridiculous to write thorough documentation for something that might get tossed. That's correct. Facebook actually has this as well, where you prototype something and then you build off of it in order to actually ship it. And that creates a lot of problems on its own because from the get-go, your product is already hampered by technical debt, but then there's no reason to invest in it if you don't even know it's going to live. So that's kind of like, it's a carpet for the horse problem. Is informal or just leave it out of loop, then most of these cut corners stay cut. And while application manually installed without documentation and even hamstrung by unscalable hacks can still be successful, these types of cut corners tend to make it more difficult for new engineers to modify the system moving forward. Yeah, you either develop now or it's like you're immediately starting the whole process just by getting hamstrung. And you only go so far, and then once the product has proven itself, then you invest in the rewrite. That's pretty much what the modern take on things are. So it's like beautiful engineering and good engineering is kind of not incentivized and almost not a thing anymore just because of this. See, what kind of problems do you find? Security teams tend to stop development work. They don't mean to do that, but a modern day security has a walker type rope. You keep your office software patched, but at the same time, problems with malicious code are being injected into complex dependency trees are becoming more common. So you want to pin your dependencies, yeah. Basically, most people don't actually deal with this, but consider what dependencies your code base relies on. I think that's kind of interesting. Because, that shit, if something changes up there, then everything must change potentially downstream from it. So I think this is a pretty basic article. I think if you're not familiar with the way how organizations affect code and vice versa, then this is a pretty good introduction to that. And it's just kind of it gives a high level overview of what to expect. However, it doesn't really go into how to deal with these things. But it's like this is just making you aware that this problem exists, and I'll link it in my in my Discord. But I think that if you're not interested, if you don't know how organizations and code really play together, and this is especially if you're at the L3, L4 level, or maybe you're at L4 and looking to make that jump to L5, I think understanding how organizations and product play and code engineering play against one another, I think this is very, very good as a beginner primer to it. So we do have my client's going to show up in about like 3 to 5 minutes. Basically, we're going to just talk. If you weren't here for the last coaching session on Thursday, he basically is going to try preparing for Uber and Facebook at the L4 level. And so we're going to talk today about like his system design and see how things have been going on that front. So if you guys have any questions in the meantime, feel free to ask. Otherwise, I'm just going to keep reading some articles. Apple added an orange dot. Ha. Alright, what did Apple do this time? Apple added a prominent orange dot to display when audio capture is active. Yep. This renders their machines unusable for live usable performance. This is also shown on external display. Ha ha ha. It's basically, okay, it's saying that, okay, it's going to try to notify you when your privacy is being violated, so with the orange dot, but then you actually get to see the orange dot as well. It's kind of weird. Okay, click the orange dot and you'll see a pop-up showing the mic. Useful, but when it's on your external displays, when you're mirroring, blah blah blah. Basically, they want to actually hide the dot when you're trying to mirror the display or go somewhere else, you know. And so this is kind of interesting. I think this is more like a product choice and a small oversight. You know, like you want a privacy notification to show up on your other monitor. It could be a yes or no, and it should be configurable. But at the same time, if you unconfigure it, then you kind of forget about it as well. So I think Apple chose the conservative route. So this is kind of just more or less a consequence of that. Oh, it looks like there's a fix. I'm actually curious what this fix actually entails. Un.m, git clone, and then they run a make file. Make file is probably composites m. So this looks like a C file. I don't know if anyone can actually read this. But if anyone actually understands what the heck this is, let me know. But it looks like it's just like some visual. Oh, AppKit. Okay. Create value for window, set attribute window, attribute position value. Interesting. Okay, it's actually really simple. Actually, it looks like just some small program that does some overlay, but interesting. All right, give me a sec, guys. I'm gonna go get my client, see if he shows up.
Recording in progress.
All right, let's see. Yo, what up? Hey, people are showing up in chat. What's up, y'all? Hey, we're gonna be talking to my client in a little bit. Yeah, remember, keep in mind, guys, we've been at this for a while, so you know, if you guys have any questions about, like, for him, for me, what we're gonna be doing or how progress has been, yeah, let me know. We're gonna try to get him to an L4 offer, and I think we're really close to it. He only has 1 year of experience, by the way, so if we can get an L4 offer for him, that'd be really fantastic. And I think the last time I chatted with him, he said that the Google recruiter was trying to push for an L4 offer as well. But let's see what he says. He says he's running a few minutes late. So if you guys have any questions, come on, just lay it on me in the chat. Ooh, SpaceX sees COVID outbreak. Slippery slope of addiction. The death of feature engineering is greatly exaggerated. What the fuck are you talking about, man? There's now 8 up other things like NLP. Working with product teams to deploy models in production. I realize I'm not the first person to raise this idea, but some thoughts I've seen discuss why feature engineering is going away anytime soon. Oh wait, hold up, he showed up. So let me bring him on and then we'll talk. Hey man.
Hey, Edbert.
Hey, how's it going?
Good, how you doing?
Hey, I'm doing good. Yeah, catch me up on everything you said. Google is trying to push for an L4. How has that conversation gone? Have you scheduled Uber? And, you know, like, how's your studying been?
Yeah. So Uber, I followed with the recruiter. He got back to me this morning and said like he followed up with the team, and it seems like the team is waiting for confirmation from the manager. He said he's gonna try to follow up tomorrow and the day after if needed. And he would just get back to me as soon as possible. So from what it looks like, I don't think I'll be able to get it scheduled like maybe Wednesday. But if they do get it back to me tomorrow, I could say like Thursday. If not, then next Monday or Tuesday.
Okay.
For Uber. And then for Google, yeah, I was just like, I did my second team match today, and it was pretty much like just two teams, two team fit calls. And after the call today, I told my recruiter that I'm just moving forward with this team and stuff. And then he essentially mentioned that he's gonna try to push for L4, and that's when I asked like, don't like L4 need like a design round? And apparently he said no. So that's why I got a little confused, but I pretty much pushed on it. It's like, so do you mean like L4 as in like mid-level and not like entry and new guy? And he's like, yes. So I don't know what's going on there, but I mean, I'm not against it. So he's just gonna try to get a statement of support from the manager and then submit it to the hiring committee and see how that goes.
Okay.
But that doesn't really change the plan that we have. And then for studying wise, I feel better studying. It's just that I feel like with grokking system design, I kind of find it hard to kind of absorb the material. Like I'll be reading them and stuff, but it's just like I just find it kind of like hard to absorb, mainly around like questions that I have. Like I'll be reading it and like they talk about how they want to do this, but I have a lot of questions and it's not answered.
Mm-hmm.
In the guide, it's like they decided to do this and that, and then I'm like I have questions like, oh, why this and why that, and doesn't this pose that problem? But they don't actually
Wait, slow down. Were you talking about this? Are you talking about like the Google guide, or what are you talking about?
No, I'm talking about the grokking system design.
Oh, okay. You're talking about grokking.
Yeah. So yeah, when because like they'll be explaining about like, oh, we choose this caching strategy, or like we choose this and that. But I sometimes have questions, but they don't go like further into that. So
Okay.
yeah, but I mean, I've been studying that and also just like reading a couple more blog posts, mainly from like Facebook's engineering blog on like some stuff that may be relevant to the system design interview. And yeah, I did some coding, but I wouldn't say I did a lot of coding, mainly just like reading system design.
Okay, let's go through all the things you mentioned, quite a bit to go through. First, okay, Uber, we might not even get confirmation by this week. At earliest we get it by like Wednesday. And then how about Facebook? Have they gotten to you?
No, they haven't gotten back to me yet.
Okay, Facebook, no option. Okay, so what I want, okay, so how are you feeling on a scale of 1 to 10? 10 being ultra giga stressed out, 1 being like, holy shit, I have nothing to do, I'm bored out of my mind.
I would say 2 hours ago I was at like an 8 or 9.
Okay.
Because of work. But I would say now like I'm at like a 5.
Okay, good.
Yeah.
Good. Okay.
Yeah, I just like pretty much like try to put like work away from my mind. I didn't feel that bad studying throughout the weekend. It's just like work today was like pretty bad in terms of on call.
Good. All right, that's fine. I'm more worried is whether or not the studying is having an effect on your mind. It doesn't sound like it is, so let's try ramping it up a little bit, especially in preparation, just in case we need to pull out the Uber and Facebook card for us. But fingers crossed, maybe the recruiter can pull for an L4 for you, in which case we don't need to execute on it, but we should still try our best here.
Yeah, because I don't know, like, yeah, like I don't know what's, like, because I didn't really mention about the L4 thing, but he just kind of brought it up out of nowhere, so I'm not sure like where where that came from.
Okay.
But then knowing Google too, it's like I feel like we would probably still need to do Uber and Facebook if anything. Like I just have a feeling like hiring committee is going to be like, oh no, this guy only has like 1 or 2 years of experience, and like we should just down level him to L3 because I think they down level people a lot. So
yeah. I mean, if you fuck up in the interviews, they will do that. I mean, that happened to me. But you know what? If you can just say, hey, well, Uber is going to interview me for L4, Facebook's going to interview me for L4, and as long as you mention that to him, I think he's got it. He understands what you're saying here. So as long as you mention that, you're fine.
Yeah, he knows I have a L4 interview coming out with Uber as well, my recruiter.
Good. Okay.
Yeah, and he knows like my offer with Amazon is like on the table because he thought because I told him like I'm in the team matching phase, and then he asked me if I have any offers. I just told him like Amazon has already offered me before even doing the team match.
Okay. I'm gonna tell you this right now. This Thursday, this Friday, is the 24th. The earliest we can even get an interview would be the 23rd. I don't even think we can fit. It's either going to be either Uber or Facebook. And if I were you, I would just go with Uber, do the interview, and then do Facebook New Year. Because chances are you're not going to be able to get something for the 27th, 28th, 29th, or 30th. Everyone's fucked off.
Yeah, no, I get that feeling too. I even if Facebook gets back to me like this week, I don't think anyone's available to do an interview anytime soon.
Mm-hmm.
Realistically saying, yeah, my deadline is like if Facebook doesn't get back to me by like first week of next year, then what do we do? Do we just like tell Google and like Amazon to wait longer, or?
That's a very good question. I'm gonna say that if Facebook doesn't get back to you, they don't care.
Yeah.
We're only at Facebook for the L4 offer. That's it. We want the offer in hand so we can go to what we really want, Google, right? This is the whole. So if Facebook doesn't get back, fuck them. You know, we did what we could. So we just need that. We just need like ideally an offer or something that convinces Google, hey, you need to consider me for an L4, and this is my competing offers. That's really what it boils down to. And of course, we can try to keep pushing Facebook to do something, but you know, again, this holiday time is like not much we can do. But the good news is that you will have the break to study up a little bit more. And so what I want to do is actually give you something a little bit more sustainable because I know you have work, right? Basically up until like I would assume the end of the week, and then after that it's kind of like whatever, right?
Yeah, I mean, I haven't decided to take any days off yet. I might take like additional day or two off, but like I'll pretty much be working.
Okay, that's fine. What I want to do actually is take this time to actually show you how to study grokking because I get the feeling that for product, you're not too familiar with it. So let me actually show you this. I think this session is going to be more of a, hey, here's how you study, here's how you actually do this. So
yeah, I think I think that would be pretty helpful because like you mentioned about like studying it, but I'm like I feel like with coding it's like pretty clear. You like told us like, oh yeah, do this, do that. These are the steps. These are the mechanism. But with system design, I'm not quite sure like how do I go by it. Like because like with DDIA, it was just more like reading and absorbing. But with grokking system design, it's different. So.
Yep, it is a little different. But the fundamental question, you know how for the product design, we've been always asking ourselves, and in the coding interview as well, we've always been asking ourselves what the inefficiency is, how we can solve it, et cetera, et cetera. That does not change, actually. Because, you know, asking ourselves, how is the user expecting this? How does the flow of data work? It's the exact same thing. It's just we just use more technical components to handle things like with load balancers and caching instead of trying to, you know, change the language on strings or something like that. The point here is that whatever frameworks that we have, they don't change. It's still a top-down approach. And I think I showed you the tiny URL video that I made.
Yeah.
It's always like a top-down structure, right? You start with your basic interaction, ask what can fuck up, what is going to be the complexity if we throw like a high volume of traffic or whatever parameters are with our, with our system that's growing.
Yeah.
And then we just keep going on from there. Okay, what if this fucks up? What if this fucks up? You know? And eventually you start getting down into the details where DDIA becomes relevant. So in the store, if we are doing an interview, first 10 minutes gathering requirements, mid 10 minutes is like just growing the system and then putting those basic components. Last 10 minutes is going to dive into one or two of those areas. And that's where your DDIA knowledge kicks in. So let me actually show you how I would do this. So, but do you have, what's it called? Your attempts at solving the problem when you were doing grokking? Do you have like a...
no.
Okay. You don't have a log?
No, I wish I did. I actually, I don't have a log on those. Okay.
So going forward, and I want you to take notes here. First, I want every single problem that you do here, I want you to do it like you did the coding interview, for the data structures and algorithms, where you have your solution and then you try to reverse engineer what steps you took, right?
Yeah.
Okay. This one's gonna be a lot trickier than a lot of other things. So let me go through my step. Let me go through my Actually, let's do pastebin. So the reason why this actually is difficult is because, like you said, it doesn't tell you why they chose certain things, right? They
Yeah.
only tell you what it is. They don't tell you why.
Yeah.
And
They sometimes tell like a very high level like, oh, this is the basic why, and this is why I picked this, and then this is
yes.
why it wouldn't work, and this is why we end up with this. And then like they just kind of stop it there or end it there, and like I have more questions.
Uh-huh. Yeah, it's just like, why did you choose this? Why did you think about this? So that's kind of the hard part, right? So our goal here is like we want to be able to use our approach, but then use this as sort of like an answer key. You know, like back in college or high school, you had the answer key in the back of the book, but they never told you why the answer is the way it is.
Yeah.
It's exactly the same thing. So, for instance, let's say I'm designing a paste bin, right? You see my screen here.
Yeah, I can see it.
So, like first things first. I showed you before. You want to start with your functional and non-functional requirements. Like before we start off like a user expectations, right? This is more or less kind of the same thing, where instead of saying, "Hey, this is what the user expects from our product. This is the way our users should expect our system to behave, and here's how our system should behave in general." That's just your functional and non-functional requirements. Do you understand that?
Yeah.
This is the only thing that's like one of the few things that changes between our product and our normal system design, right? So, for instance, let's look at this, right? If we think about our functional requirements, it's going to be what the user expects from us, right? So the user should be able to paste their data and get a unique URL to access it. That's pretty self-explanatory, right? Users will only be able to upload text. We don't want like images or anything else. Although personally, I think it's just kind of evident that you only want text data here. So you may or may not explicitly put this. But yeah, it's kind of, you should say that at least somewhere that is all going to be text. Data and links will expire after a time span. Okay, so there'll be a TTL, and then users should be able to pick a custom alias. Non-functional, blah, 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 highly reliable, highly available. So you can use the CAP theorem as a way to kind of figure this out. You know, what attributes do you want to keep in a system, and what would you expect people to how the system should handle things. So that's basically what all this is. It's not a whole lot, right? It's actually very simple, and it's really only trying to target the very core idea of what Pastebin does with like a few bells and whistles, like custom alias and whatever, right? Like this guessable thing as well. Like it's okay to have, but it's also like something that it's not giga important. Like for instance, I would not be remiss if you didn't write this. So I wouldn't feel too bad, but stuff like this, where you should only be able to upload text, you upload data, and you capture the core idea of the system, you should be able to explicitly say this. But random shit like this is like, okay, it's kind of okay if you miss it, right?
Yeah.
Okay. So then design considerations is like, okay, what are your limitations? What are the things that can go wrong? And can we limit ourselves in order so that these things do not happen? So, you know, what if someone dumps a shit ton of text? You know, that could be like a gigabyte or something like that, right? It could be like a fucking novel. Well, we want to limit the amount of text, right? So these are like looking at things that can obviously go wrong. So remember how like before we were talking about, oh yeah, what does the end user expect from our system and with language strings, and what are like, what do we need to do with language strings? It's pretty much the same questions. Like, what the fuck can go wrong immediately right off the bat? How can people like, you know, kind of abuse our system? Go ahead.
So is this something you would do right after like the functional and non-functional requirements?
Mm-hmm. I would do that because these allow you to really just limit your scope. Because technically, even if you have the functional non-functional requirements, there's a lot of different like ways that you can go with this. You know, what if we want to upload full-on fucking novels, or you know, or only novels even. Or maybe like if we didn't have this text, let's say we had this text requirement as well. You know, let's custom alias. Do we want to have swear words in our alias as well? So it's like these things that we might want to like limit ourselves, because if we limit ourselves, then that's less things that we need to consider. It's just a way of like, believe me, these systems are very, very complex already. So let's start with, we just want to limit ourselves so that way we can have a very simple, very basic system that we can build out. And then if we want to introduce complexity, we can do that later. But having something very simple, straightforward at the very beginning is almost always the right answer. We can always add complexity, but it's very hard to make a complex system more simple without destroying its existing functionality. Does that make sense?
Yeah.
All right. Next thing. Okay. So capacity and estimations. This one, Um, I'm gonna say mostly like, you don't need to get the numbers right. In fact, I don't think I would get the numbers right. I think this is just more or less trying to express to you how much traffic are we gonna get. Are we gonna get like a shit ton of reads and writes? Are we not?
Yeah.
You know, it's like how much data do we actually need? Is this gonna be a real problem? This is more or less just kind of telling you, hey, is this area gonna be a problem? So for instance, read or writes traffic, I would say 58 reads per second is not that bad. But like, and even 22 gigabytes. I would say,
small,
but
yeah.
51 terabytes is actually going to be very, very large.
Okay,
you know?
yeah.
So this is actually going to be a problem. So the storage estimate is going to be a problem. Bandwidth estimates, the total get sent to users will be 6.6 megabytes per second. So the bandwidth is not going to actually that big. But like I said, you should keep these numbers in mind. But it's not that big. It's not like the most pressing concern. This is the most pressing concern, the 51 terabytes. And so this is like your order prioritization. It's like, there's like traffic, there's storage, and then there's bandwidth and memory, And so like 10 gigabytes is nothing, right? Like my fucking desktop can handle this. So I don't give a shit about this. I don't give a shit about this. Maybe later I do. But the big one is going to be this fucking 51 terabytes. So I know at the very least I'm going to have some choke in the database. Once I solve this, then I can probably start dealing with these in the order that they are a problem. So the next thing here that would be a problem would probably be this 58 reads per second. Does this all make sense so far?
Yeah, it is. It's just like these numbers, like to be able to come up with them. Like obviously I could ask questions like, oh, daily active user, and like I would know like how much space a typical image or like string would be. But I guess it's just like, because like I don't have a calculator like on hand when I'm doing the interview, right? And so like I have to kind of do these, and that's why I'm like, am I actually expected to like come up with these numbers?
I would say no. But you should instinctively have some kind of knowledge of where the biggest pain point is going to be. Like, imagine you didn't know these numbers, right? Think about, like, if I said, what out of these 4 categories, traffic, storage, bandwidth, and memory, which one's going to be the biggest pain?
Storage.
Yeah. Like, even without the numbers, you could probably, you could tell me that, right?
Yeah. Yeah.
The numbers are just really here to make it concrete and to prove that it actually is an issue. But instinctively, you should know this. Now, of course, you're gonna want to ask you're gonna ask the guy, right? Oh, well, we need to have a maximum of 10 megabytes of data. What is our read-write ratio? You're gonna ask him for that as well. You're gonna ask him our traffic estimates. How many reads are we gonna get per day? You're gonna ask him for all these before you make that judgment call. Like, because what happens if you expect, a gajillion writes per second instead of like just 12 pastes per second? That changes the dynamic entirely, and that not only is your storage estimates going to be a problem, but your bandwidth estimates would actually become a problem as well. So it would then change. It might knock the priorities out of whack, and in fact, maybe in some cases, the bandwidth might actually become a significant problem more than the storage.
Yeah.
But that's what I mean. You need to be able to ask these questions. So when I look at this, when I see, hey, maximum size of 10 megabytes, that means that, okay, at least I should be asking this question, right? If I see write requests in this solution, I just say, okay, I should at least ask this question as well. So as long as you've asked these questions on paper and you've written out, hey, this is our concern, and you assign some arbitrary number to it just in lieu of the interviewer, just for the sake of practice, then I think you're fine.
Okay.
So it's like these numbers, I would say even if you want to look at it for capacity and estimation constraints, like for the first few pieces, all the way up to system APIs, you can literally just write it down, and then replace the numbers with their numbers. That's the way I would do That's the way I would do these functional, non-functional, and the capacity estimations.
Like wait, say that again. I would write down.
So if I'm doing a practice problem like this, what I'm going to do is I'm going to write the requirements and goals of the system. I'm going to compare it here to what the book has, and then just compare it, and then use the books, right? And then I'm going to keep going. Same thing with design consideration. I'm going to say, hey, maybe there's some shit I need to think about. I'm going to write down what those design considerations are, and then compare it with the book, and then use the book's limitations, right? After that, I'll do the same thing with capacity estimations. I will ask myself the right questions on what to do, what are the things that are blocking me, and then take a look at this, and then use the book's estimations, right? After that, I will then just do the problem, do the rest of the problem on my own. Does it make sense?
Yeah.
It's just for us to set ourselves up, because it makes it doesn't like help us if we get the wrong functional requirements and the wrong estimations. We'll be solving a completely different problem, and so the answer that the book gives us is not gonna make any sense because we've made different assumptions.
Okay.
So then after that, system API, I personally, this is where we actually start to do the problem. This is where I would actually start like with the user server database, recognize, hey, wait a minute, the storage is going to be a problem here. So how should we shard our data? And then I would also come with a schema, high level, and then just be able to start working through the problem. And then as I grow the problem, I'm going to get to a point where I think, okay, this looks pretty good. I've solved the API constraints. I've solved all these different things, the high level design, database design, component design. I don't actually look at this. I just kind of know instinctively I need these things. And then once I'm done with the entire problem, then I'll go back and look at this. Like, okay, did I answer the question about API design? Did I answer the database design? Did I answer this? And if I didn't, then I'm going to go back and add that, But ideally, what should happen is that if you're doing the problem right and you're following the framework, you will naturally produce all of these. You don't have to think about, oh, well, do I need all these? Like, oh, did I remember this check mark? Remember, the framework here, and it's always the same question. What is the inefficiency, and how can I fix it? And using these components. And eventually, you'll naturally ask yourself, what is the schema I'm using here? What is the high-level design? What is the data store? What does the shard look like? You will ask yourself these questions, and you don't have to remember this checklist at all. Does that make sense?
Yeah, that does.
Okay. So let's say you got through the problem, right? You worked through it, you grew the problem, you started with like the basic problem, and then you went to sharding, schema, whatever. After that, I would compare the schema. I would start like going through all this and comparing to make sure that I got everything that they did. So if I have like an add paste, I want to make sure that these guys, I had the exact same thing as these guys. And if I didn't, what did I fail to forget, and how can I, prevent this in the future? It's the exact same exercise that we've done so far for the coding and data structures and algorithms, where we just compare like our answer, and then we ask, okay, what path could I have taken in order to get the answer that they did? That's really it. It's the exact same exercise that we've been doing.
Okay.
And then the same thing with like high level design. Okay, use S3. I think we talked a little bit about.
Yeah. Does it?
Good.
Sorry. Does it matter if I do like the API design first, or should I like talk about like the schema first, or like just kind of draw out like the very high level basic design?
I want you to grow the problem. I want you to grow and think about and grow the problem and solve the problem as the problems arise. You don't need to do this in order that the book says. In fact, I think it's a little stupid. Because
because like when I was reading it, it seems like they tend to do the API design right after the capacity estimates, but then like the way we've been doing it is like once we have the functional requirements and all that, we have the scope, we start with like the very basic solution, and then we talk about schema, I think, and then I think we typically talk about APIs after schema and not like the way they do it. Yeah.
It may or may not be. What I want you to focus on isn't like, oh, I need to do the API, then in the database. I don't want you to think like that. I want you to think, what is the most important thing about my system right now? And the system API is more or less just here to say, hey, this is how we access our points, and this is how we capture the core functionality. Now, some of the, paste bin might be just so obvious, like, oh, I want to add a paste, get a paste, and delete a paste, that, we might not even really care at this point. But at sometimes, maybe we do care, Maybe there's time to expiration. They have a TTL here, right? So maybe define the API might be okay because, eventually we are going to need to implement that in the database. Or maybe we just have this, we start with the database, start very simple, and then add the TTL later because, these pastes they expire is not necessarily all that important, but it could be. My point here is that it's up to you to decide what is the most important thing to tackle about the system right now. And of course, you can always go back and revisit it and revise, because I would argue that compared to actually uploading a paste and deleting a paste, this expire time is not even that important. I would personally have I would have mentioned it in passing and then go back and actually add it. But as far as the core thing, first pass goes, I would not do it. I think this is just here because the book, like I said, this is more or less like a high school textbook with the answer in the back. It's just the way they organize it, and this like quote unquote the answer, but they don't tell you how it's done.
Yeah.
So
Yeah.
I'm gonna say that this is just really the answer, and just try to figure out how they try to reverse engineer what they did. That's really it.
Okay.
That's yeah. So like for instance, if you miss like last login, well, why do we have a last login? Do we even care about the last login? Like, why would we care? You know, because sometimes like you might straight up disagree with it. Like for instance, like if our focus is on getting a pace and deleting a pace, why do I need to care about the last time the user logged in? Why do I need to care about the creation date? You know, I mean, maybe later on we might, and it might be useful. But you know, like name and password, email, and then maybe the salt of the password, sure. But then after that is like, what the fuck? Why the fuck is this here? So this is where I would say if I can't come up with an argument for why this is here, either ask me, or if it's like so blatantly obvious it's stupid, then you can just move on. You know.
Okay.
Like I would say it's pretty blatantly obvious that the last login and creation date are not relevant.
Yeah.
So, yeah. Do you feel like you got a better understanding of how to do this?
Yeah. Yeah. I think definitely way better than how I was like doing it.
Mm-hmm. Yeah. Don't worry about like again. This is just the back of a high school textbook. Now, did you get a chance to read all the basic system design stuff? Like
Yeah, I did.
Great.
I did.
I'm gonna say that leader follower is and quorum are gonna be like, so I think you might want to put a little bit more focus in. The reason why is because it's very easy to talk about these reconciliations. Yeah, it's very easy because you know, this is stuff that this formula I recommend from DDIA as well, and they'll also talk about it here. I think this is just like more of the quote unquote easy to digest version of it.
Yeah, I think I'll have to look up for that because I basically got like a free PDF version, and it has everything except for like the last four or five things. It doesn't have forum, leader and follower, heartbeat, and checksum. Heartbeat, I assume, is that's just basically servers telling the manager or like the shot manager or whoever that you know they're still alive. Leader, follower, quorum. I mean, those are things that I've read in the DDIA book, and I don't expect Grokking to go even deeper than they do. So.
No. That's fine, but you just need to recognize problems where that actually does become relevant, and they'll become relevant when you start doing harder problems like the Uber design, Uber backend, and shit. Yeah. So I would say that, yeah, you know, proxies. I've never had to use a proxy to be honest. I've never rented a proxy in a interview.
Would you like? But couldn't you also use a proxy kind of like as a gateway / load balancer?
Well, why not just use the load balancer as well? Why not just use a straight load balancer?
I don't know, because sometimes you may want to have a gateway to translate the incoming data to some protocol that you know your internal systems use. For example, I think like Facebook uses Drift, and like you would just take in JSON data, transform it to Drift, and then you pass it into internal.
I understand what you're saying, yeah, and that's an argument that you could make. Like you use a proxy in order to have like an edge gateway. So that way you can, what's it called? When people want to make changes to like the API, you have like some buffer so that you can load all the changes before you fully commit them. I can see that argument, and as long as you make that argument the right way, and it comes naturally from your from your problem, and you say, hey, this is a real problem, and this is how we're gonna solve it, then that's fine. But I've never actually had to mention proxies myself. Most of the time, we just focus on database and the server, and then like SQL, NoSQL, and like some other random shit, but I've never actually had to do it. But if it comes up for you, and you should be prepared for it.
Okay.
Yeah. Heartbeat, checksum. Like I don't know. Like this is like a random fact, and it's cool to know, but like it's not imperative. So.
Yeah.
With that, I want to actually try giving you one of these problems. I want to see how you do, and then I'll go through the grading as if you were doing the problem yourself. Okay.
Okay.
So I'm not gonna time you on this, but hopefully.
Can we do on Excalibur again?
Oh yeah, you're right. Good call. Okay, so let me go ahead. Let me send you the Collab link. I kind of want to do. I want to make this meeting short again because I want to give you a chance for you to try it on your own. I want to give you time back so that way you can give it a shot. Make sense?
Okay. Yeah.
So let's do one problem. It should take us like an hour to go through all this. Yeah. Okay, so do you have it?
Are we in the tiny URL one?
No. So I'm going to give you a different problem.
Okay.
Let's see. I probably shouldn't give you the Uber backend one because I think I'll just like say more than I know. I'm supposed to let on, you know. And I'm not gonna give you one that's too hard either. So let's say. Okay, so let's do this. So let's design Instagram. Let's design a photo sharing service like Instagram where users can upload photos to share with them with other users.
Okay. Let's see. Let me pull this up here. Okay. So let's just start off with like the requirements of this problem.
Sure.
Why is it so small? Okay. So users can let's see, upload photos. Users can view photos. So this basically means we have a news feed.
Okay, sure.
Like some kind of feed. Let's see what else. Do you want to do likes? I guess that your likes is pretty like critical. Users can like.
I would say I understand what you're just going for. Let's not focus on the likes. Let's just focus on the photos and follow and newsfeed themselves.
Okay. Okay. So I'm also just gonna say like photos only and no videos. We can talk about that later. I'm just gonna list down like some of the nice to have. If we do have time, we can say like, comment and video. Those could be things that are good to have. As for the non-functional, obviously we want it to be highly reliable. If a user does upload a photo, we should not lose it ever. And like we definitely want it to be highly available. Also, like obviously we do want it to be like pretty consistent too. But I guess like in this case, I would go for like availability. Availability over consistency. Like if a user couldn't see like a photo uploaded by another user from another region for like 2 or 3 minutes, I think that's totally okay.
Okay.
So I think that's
okay.
pretty
let's
basic.
Also, I think that's fair. Let's also add in the ability to search.
Okay.
Search based on photos or video titles or whatever. And let's also add follow. I think what you did here was perfectly reasonable. You kept it very simple, which is I'm okay with, and your highly functional thing. You also mentioned that you want your okay trading off consistency. Now, when you do this exercise, I want you to be I want you to be as atomic as possible with like your considerations. So, for instance, you invoke the cap theorem here, and I think you kind of remembered that. Cap theorem. Most of the time, you pick P. So you're almost always going to choose between C and A. At least acknowledge which one of the cap theorem you're actually going to use. And then also, I would say think about latency as well. Like, how long does it take for us to search? How long does it take for us to generate those news feeds?
Yeah.
So it's not just cap and reliability, but then also latency as well. I think those are going to be your go-to non-functionals.
Okay. Let's say we definitely want to have low latency. I guess like for newsfeed generation, we can say anyway below like 500 milliseconds would be okay. Does that sound reasonable to you?
500 milliseconds? Okay, sure.
Yeah. Let's just go with that for now. Or like 500 to a second. Let's see. Users can search. As far as I know, like we don't really have like titles for like photos, but we can say like we can search based on description of photos. Okay, so that's like the requirements that we have. Let's see. Let's see some of the limitations or like considerations that we want to have. Let me list them down. So we also mentioned. So photos. I guess like one thing is like how big do we want a photo to be, or like how large a photo can be, like in terms of like size. Because like some users may have like pretty high quality photos, but we may want to compress them. Let's say we want to store photos as like I don't know how big like Instagram stores is, but let's assume like 1 megabyte. Would that be reasonable?
We could do that. I'm gonna say let's shoot for 200 kilobytes. I think what you said makes sense as an upload, but the thing is that we do want to downsample some of these things.
Okay.
The reason why is because like even if I upload a 200 megabyte photo, there's only so much resolution that I can see on my phone.
Yeah.
So this is like an example of, okay, what's going to be reasonable here. This is like something that is not like a thing that you can memorize. This is just like, what does the end user, like, what can we get away with because the end user won't fucking notice?
Yeah. Okay. All right. So let's say we limit 500 characters for the description.
Sure.
That's
also something.
For now, like, yeah. For that's like for now we can say like they shouldn't be any limit to following. I guess that would be a pretty shitty thing if we limit the amount of users a user can follow. So let's see. Main thing are going to be photos, uploading and viewing photos. Okay, so I think those are going to be the considerations we have. Let's start with something simple. Let me pull out some boxes.
Okay, are these all your considerations, or is there something else you might be missing here?
Let's see. I guess I want to limit like the, no, 50 is a little too many. I would say like maybe 15 characters if for searching, because I don't want a user to spam the search bar.
That's not the right answer. That's not the right question. I think there's still a fundamental thing that you haven't asked about yourself about the system. I think it's a pretty glaring one if you think about it.
Okay.
What question have you not answered?
Newsfeed.
More about your system itself. I mean, newsfeed, sure, but I think it's something more fundamental.
Something more fundamental.
I'll give you 30
user
seconds.
can upload. Okay, user can upload photos, can view photos. And it's not like, so it's not cross-region because that's fundamental. I'm missing something fundamental.
Are you gonna you got it, or do you want me to ask?
I'm gonna feel pretty dumb, but yeah, like give me the answer.
How many users are using your system, dude?
What?
How many users are using your system?
Oh fuck. Okay. God damn it.
I mean, that's kind of important. Like designing a photo sharing system for like one person is different than a million people.
Yeah, oh god, I was like so focused on like the stuff we listed down here. I was like, what is so fundamental? I was like, these are like as fundamental as it could get. So I was like, oh god, pretty dumb for it right now. Okay, yeah.
And then also with that also implies another thing. What else?
So we have like amount of users, daily active users, and also amount of photos being uploaded or viewed every day.
Yep.
Yeah. So let's say we like I would say like Instagram has like a lot of followers. Let's say we have like 1 billion users.
Let's say we do have 1 billion users. Let's say we have 1 to 10 million daily active users or something like that.
Yeah. I was gonna go with like one. Okay, so let's go with 100 million registered users. But daily active users would be say 10%.
Sure.
And 10 million users, daily active.
You're gonna know more than me. I don't work at Facebook.
Yeah, and then let's see. I typically view a lot more photos. Let's say like one day we can view up to like 100 posts.
Sure.
Yeah, 100 photos, but like I would say out of this 10 million, I would say like maybe 10% upload a photo a day.
Okay.
So let's just say 1 million photos a day.
Okay.
And this also gives us, I guess like this kind of gives us some leeway into the next part. So we mentioned that we want to store 200 gigabyte. So we have like 1 million photos per day. I really think this translates to what?
I would say if you have 1 million photos a day, that's quite a bit. So how many photos per second is that, or do you want to play with? Do you know why? Okay. And do you know why I'm asking this question?
Because most I guess like rates are usually in per second. Is that why? Or
no, it's a lot simpler than that. Don't be too technical about it.
Because you can make the numbers smaller and then make it easier for calculation.
It's more that there's a few dimensions to this, right? it's not just
Yeah.
your daily active users. It's also another measurement of your bandwidth, right? Your traffic.
Yeah. Yeah.
So that's why I'm saying that. Like, if you think about like a million photos a day, it's like, okay, but then what does that break down to on average per second? So it's like that will tell you how many, given the average size of the photos, and then the number of photos you're getting per second, you can figure out the bandwidth of what you need to deal with in your system.
Okay.
You see how like simple that is? It's just like, okay, well, not just the storage that we're dealing with, we're also dealing with the amount of data that goes through our system. So there's just another way of figuring that out.
Okay. So like 1 million. Let's see. I don't know how to do this right now. Half a day is like 500K.
For now, I'm just gonna give you a random number just for the sake of time.
Okay.
Let's say that you get like 50 to 100 photos every second.
Okay. Let's say we have 50 photos per second.
Sure.
That's gonna be 200 gigabyte. Kilobyte. That's 50. Pretty much have like what?
Like 10 megabytes.
10,000.
That's 10 megabytes.
And megabytes per second.
Mm-hmm. Yeah.
In terms of upload. Let's see. Let's say the amount of photos being viewed per second would be a lot higher.
Sure.
We can say the read to I could say like the read to write ratio would be like 10 to 1.
Sure.
You could say like 500 photos.
I mean,
second?
I think this is reasonable. I would personally say more like 50 to 100 to 1, to be honest. But
Okay.
I think that's okay. I understand where you're coming from, but at least you considered it,
Okay.
It's
Let's
fine.
just go with
Let's go with your numbers
100.
right now. It's fine.
Okay.
Okay. And then one other thing you want to consider is the amount of storage, right?
Yeah.
How long are you going to store these photos for?
I guess like I would put it to 10 years because I can't imagine like my photos being deleted after 5 years or like 7 years.
Okay.
But that would that be a good thing during an interview? Just like because like realistically it would be like 10 years at least, right? But then like would also be like extremely large.
I mean, what you're saying is not necessarily wrong. Keep in mind. It's just what you think reasonable user expectations are. And this boils down to a little bit of like your product mind kicking in, right?
Yeah.
What would an end user realistically expect?
Yeah, because I would expect it to be like there for like at least 10 years. Like I do see my photos from like 10 years ago. And so like at least from a basic design, like can I expect 10 years? But then like, okay, this will be a lot. Let's see, we have 10 megabytes per second. Let's say a day, how many that would be? Let's say we have about like 100 gigabytes per day.
Mm-hmm. Sure.
That would be
Let's
kind
say
of
that.
reasonable.
Okay. So then,
Yeah.
you basically means then how many servers? I imagine you already know that you're gonna store a lot of data, right?
Yeah.
Okay.
So yeah, and we were gonna store a lot of data. I guess like a typical commercial grade server can store up like 4 terabytes, I believe.
Sure.
And like based on like 10 years, I assume like we would have like thousands of server, if not tens of thousands.
Probably like let's approximate like 1,500 to 2,000 terabytes. But I'm giving you the numbers right now. But it's important that you are able to do this yourself pretty quickly.
I think I'm probably gonna take some time out the next couple of days just to like sit down with the numbers and just like play around with like different calculations.
It boils down to like being able to convert kilobytes to terabytes. And personally, for me, I always do things in terms of 2, 5, 10. The reason why is because it's so much easier to do numbers in terms of this because you can do it very fast. If I come up with some weird number like 4 or 12 or something like that, I can't math it. So the easiest way I found to do it is literally just pick numbers 2, 5, 10.
Yeah, these are fine when it's like just like 2, 5, 10. It's when you include time because time is like 60, like 365. I think that's when like it messes me up. But if this is like the 2, 5, 10, like I'm typically okay. But okay, let's just say we have like 15 to 20K servers that we need, and we can move on to the next part. Let me draw out some stuff. Okay, so we can start like pretty simple right now, even though we did mention that the load would be pretty big.
Okay. Yeah. So this is where you should be able to ace the interview now, because it's gonna be everything that we've talked about. So let's see how you do.
Okay. So yeah, we have obviously like pretty simple, like off the bat. I'm trying to, how do I get database? Do they not have, can you, or should I just?
Oh, do you want assets?
Yeah.
Yeah. Okay. So here's a baby Yoda. You want to use them? Server, object store in case you need it. Relational, application server. I'll give you a load balancer, DNS, CDN in case you need it. Web. I'll give you a cache. And then there should be a pipeline in here somewhere. Yep. Okay, so you have a little stuff available to you. And I guess I guess cold storage in case you need it.
Okay.
Yeah, so this should be everything. Go ahead. Go nuts.
Okay. So yeah, honestly, like in the most simple case, let's talk about like the kind of data we need to store. So we need to store photos. We need to store user data, and we also need to store metadata. I guess I should say photo metadata.
Okay.
Yeah, these are like the three types of data that I think we should have. Photos, we can obviously choose between blob and file storage.
Okay.
I personally don't have a big preference, but we can go with file storage.
Okay.
Here. So let's say we have, this is going to be our file storage. For photos, I'm going to have two DBs here for now.
Okay.
One for, why is it not doing? It's a little laggy for me. Okay, so this is user. Wait, why is it not? Okay, screw that. I'm just gonna type it outside. We have photo. So I don't know if you noticed, but it's a little laggy from
Yeah, it's a little. I can't see what you're typing, but I'm just kind of waiting for it. So.
You couldn't see anything I typed?
I can't really see it. Try rejoining.
Okay. It's not loading for me. I don't know why.
Okay, hold up. What happened? Let me see if I can re-invite you then.
Yeah. I did the refresh, but the page is just not loading.
Oh, that's strange.
Okay. It's fine. I'm back in here now. It seems like everything I typed earlier was gone.
Okay.
Let me retype them.
Yeah, go ahead. Yeah, I didn't see shit, so I was like,
Yeah. We'll remove this. Okay. So yeah, I have like three types of data right now. You can see the three stuff, right?
yeah, photo metadata, user data, and file storage. Sure.
Yeah. So I guess like we can start off like pretty simple. We can have like three types of data, and then users would basically call in to our clients' mobile apps. Will hit the web server, and then from there we will then store all these stuff. Now, one thing we did mention is that the volume is extremely high, and the read to write ratio is also pretty skewed towards reading. So I'm thinking of like separating the two processes. We don't want to. Yeah, I guess we can separate like the write pipeline and the read pipeline, if that makes sense.
Sure.
Let's see. let's start out. Okay, for reading and writing.
I mean, if
let's
you're
do
looking for the
read.
pipeline, just here's one. But
Okay. Okay. I guess like wait, where's the pipeline again? Okay, I see it.
Here it is. Yeah.
Okay. Let's see. So let's say this is the you see what I typed in the
Yep.
pipeline?
I see right pipeline. That's fine. I honestly
Okay.
don't care that much.
Okay. Let's go with we write to the pipeline, and then let's assume like the pipeline would then have to. I guess like this pipeline could also help us do the whole compression we mentioned earlier.
Sure.
And then it would store to the file storage, and then I guess we would also need to store to the user data as well as the photo metadata database.
So then,
those are
what
the three
exactly are you
things.
storing in each? What's the schema?
Yeah. So let's actually let me type on this side. Sorry. I'm trying to zoom in, but it's like
Yeah, there's a little thing on the left. You see the bottom left? There's a zoom in and out.
yeah.
Yeah, that's the one.
Okay. So we have photos, or like I guess like in this case I'll call it file. We just have a simple file ID and the actual file. This will be in the file storage database.
Mm-hmm.
And then user-wise, we can have obviously like the user ID, name, email. I guess like just like the typical timestamps, like creation, last modified, stuff like that. And I guess we also want to keep track of the user that this user follows. We could pretty much like store it in here if it's like a small volume, but since we're dealing with a lot of users, let's say we have a separate table to say a user follows, and we can have pretty much follower and followee. This can be two columns. There's that, and then we also have posts, and posts will have a description. They have a file ID. This pretty much points to the ID we have in the file storage database. We also have user ID, creation time. Let's see what. Yeah, these are pretty much like the basic schema I have right now for the entities we're dealing with.
Mm-hmm. Okay, so user file timestamps. Okay, so then you are writing exactly what to the user pipeline, user data then?
Yeah, and I guess like we could just like store like the total number of followers here as well in the users, because we don't want to pretty much load up all the followers when we load up just a user profile.
Okay.
So that's why
So I guess, well then, which of these functional requirements are you trying to satisfy? Upload, view photo, search, or follow the users?
The schemas here would basically handle like the stuff we have in the function. I guess like the only thing that wouldn't handle that well is the search, because right now we basically just store everything, but we have no like anything else to kind of help the search. But in terms of following, this kind of gives us like the basic data we need to display like following, viewing photos and uploads, stuff like that.
Okay, so this is just a general write pipeline, right? Okay. I see. So you're funneling the little tidbit here. And this is gonna be interesting because a lot of times these problems they do have a lot of little requirements, but it's up to you to decide which one is the major requirement and the minor requirement. So follow me on this. Which one do you think is the major requirement here?
Photo uploading.
Yeah. So I would not bother with like saying everything's gonna be funneled through the right pipeline. For now, I would focus more on trying to make sure that the photos are done because that's the core requirement, right? You can then, after what you're done with that, then you can tack on the follow and say, hey, yeah, let's towards the same pipeline. But it might seem like a subtle difference, but it's really not. The reason why is because you are assuming too much responsibility at the beginning. Because the upload photos and view photos, I can kind of see doing them in tandem. But uploading photos and following other users, doing that at the same time is just very, very complicated. I don't want to take on more responsibility, especially if it's like two separate ideas.
Okay.
I would not do that. So I would say for now, stick with the photos, clear the photo condition, and then do the next one. So, all right, keep going.
Okay. All right. Yeah, I know I just wrote this, but I guess we can ignore them and just kind of deal with the photos first.
Okay, that's fine. So you have the file ID, and then you have an actual file, which I assume is the URI to the actual file stored. Okay, so these are just like the file metadata, isn't it?
Yeah.
Okay, so this would actually be here, no? Or am I wrong?
Sorry, what was it?
Which database does this go to actually? Here.
So let me.
Here.
So yeah, this would be here, and then post.
I'll let you put write it in. Hello?
Do you see them? Do you see them?
Hello? I don't see anything you're writing.
Oh, yeah. Oh, okay.
Look
I'm
at my
seeing
share
it.
screen.
Okay. I actually moved them already. I guess I'll have to refresh again. I don't know why it's not
weird.
working.
Yeah, I mean, you can kind of see like what I'm seeing because I'm still sharing my screen. So if you're like,
Yeah,
hey, can you see this?
I already moved all of them to the respective databases.
Weird.
Yeah, it's like super laggy.
That's fine.
But yeah, essentially I moved so file ID, that's at the right file storage, and then at the post we go to photo metadata, and then the other two, and then the other two will just go to user database, user DB.
Okay, that's fine. I see. File ID. Okay, I see. Cool. That's fine.
Yeah. So the idea is that a user logs in, and then when they upload a file, we pretty much send it to the pipeline, and this pipeline could do like encoding depending on the format and like compression. That's the main thing, and then we ultimately store it to the file storage. And once we have like that file storage and the file ID, we can then store it to the photo metadata. And the file ID would just point to that specific row in the file storage. And like we assuming like if this is it's like it usually needs to be registered before they upload the photo. So we can also I guess we don't need to do much with the let me delete this. We don't have to write to the user DB at this point of time. We just need to write to the file storage and the photo metadata DB. For uploading photos, that's going to be the pipeline. Does that make sense?
Yeah, that kind of makes sense. So this is okay. So then, what about the read?
Yeah. So for reading, we have to start talking about like the followers now, right? Because when we talk about reading, we need to show the feed or like photos from users that this current user follows. Now, one way we can do this, not a great way, but is that we can query for all the users that this current user follows.
I see where you're going.
And then pretty much generate like all the photos. Does that make sense?
Okay, I'm gonna put a pause here because again, this is about prioritization. So, out of the requirements that we have, which one are you handling and why?
I'm handling view photos.
Okay, so you're handling in terms of the newsfeed, right?
Yeah.
But I would say make it a little simpler because then the conversation just ends up becoming design a newsfeed. Remember, our focus here is the photos. So, what I'm saying here is instead of trying to think of it in terms of a newsfeed, which is just an example of viewing the photos, why not just have a way to view the photos if, like, tomorrow we decide not to do newsfeed?
Yeah, I guess like if we need to view the photos, we can just pretty much have the server or like the web server query the file storage and as well as the photo metadata, and from there, once we have the necessary data, we can then display it to the client.
Do you understand why I'm saying this though?
To start off with like the simple solution and then kind of build up. Yeah. Like if I
Go ahead.
Because then, like you mentioned, if I dive straight into the newsfeed, it's kind of like digging into it without having like the simple idea first, and it could be that the requirement changes and we don't want to have a newsfeed and we just want to have something different.
Right. It's a matter of where the focus is. Now, if I asked you to design the news feed itself, then that could be a totally different problem, right? But
Yeah.
but I asked you specifically for like the photo sharing itself, photo sharing service. So in which case, it's like you're thinking too much like Instagram. Like, what if I have it like Imgur, you know? Then it might be a little bit different. So it's understanding where the emphasis of the question is, and then understanding, okay, this is what is the core to what I'm doing versus like, oh, this is what an add-on is. You know, I would argue that the newsfeed is an add-on to the photo viewing experience.
Okay.
So
So yeah, let's going back to it. The clients hit the web server, and then we basically query the file storage and the photo metadata database in order to show them a list of posts or photos.
uh-huh.
I'm just trying to try. Okay. But isn't it natural just to like when we talk about like viewing photos, like we want to show photos from users that the current user follows? No,
We want to just repeat that.
we want to show photos from other users that the current user follows.
Correct. But that's like follow is more or less a function that the newsfeed uses, right?
Yeah.
So you can kind of think of it, what if we didn't have the follow before? Remember what I said before? We're uploading and we're viewing photos, right? That's more or less the core of the product we're doing, right? There's no need to worry about follow and everything else just yet until we get the upload and view photos working. Remember what I said before, focus on one functionality at a time.
Okay. So yeah, like the end-to-end like sequence will look like as the client would upload a photo, it comes to the web server. We then send it, we schedule it to the pipeline. That pipeline will then do some encoding, formatting, and compression. Eventually, it will then store it to the file storage and the photo database. As for like viewing, once they're ready, the user will come in and the web server will pull it from the database. For now, like simple, we can just say like we pull like the most recent like 50 photos. If we don't talk about the concept of following, we just pull like a list of photos from the file storage and the photo database to show the user.
Okay. All right. So then basically you're just gonna have a read pipeline then. Okay. And then I guess for the sake of time, let's talk a little bit about like the storage itself. You know, how do you want to handle this big database and files? Because you could, you know, like I said, we're going to have a lot of data to work with here. So, how do we want to handle it?
Yeah. So we obviously want to shard this due to the amount of storage we have. Let's see. There are like a few ways we can shard this. One is we shard it by the file ID.
Okay. Well, quick pause. Why you're not sharding the file storage? You're technically sharding the metadata, no?
Sorry, say that again.
Aren't you sharding the table in photo metadata, not the file storage itself? Well, I mean, I guess technically you could, but yeah. Yeah, okay, keep going, yeah.
Yeah, I mean, because we will still need to show like the photos as well, right? So I guess like either way, I guess what we shot like, okay, I think like a better way instead of like thinking these as like two, we can say like we'll have like different pairs. We'll have like pairs of photo database and a pair of file storage, and so like if we have like 3 shots, it would be like 3 pairs of them. That makes sense.
Okay, I see what you're going for. All right.
Yeah. And then that should answer your question of like which one we're sharding.
Okay, now how are you gonna shard them? How are you gonna split them up?
Yeah. So there are different ways. So one is that we shard it by like the file ID or like the post ID. I guess like in let's see, what would be a better way? If we shard it by the file ID, like one simple way is like when we generate these file IDs, we can kind of put them into buckets. Let's see. We can basically, let's see, kind of do like a mod operation based on like the number of shots we have. But then that's like a pretty simple solution. And eventually, when we do want to add more shotting, more shots or delete some shots, that creates some issue. So I guess a better way is like if we kind of like plot these file IDs onto like a range of numbers to kind of allow us to do some kind of a consistent hashing.
Okay, so you're gonna shard by number, sure. You have like 10 or 15 shards, okay. And then you just auto increment it, okay. I mean that's one option. So what is another? And you're saying you're only doing do it by photo ID?
Yeah, I'm currently doing it by the photo ID.
Okay. Yeah. Okay. I mean that's fine. You know, there's another way of doing it. You can do it by the users themselves as well. Either way, I'm gonna put a plug here because I kind of want, because I think you're kind of getting the point. You're kind of getting an idea here, and I think you're a little bit slow. But I want to give you the time back in order for you to try this on your own. You didn't do too bad. And I know I talked to you a lot through a lot of this, right?
I feel like I did pretty bad though.
I mean, again, this is a learning experience, right? This is the first time you're actually trying to do this. But I'm going to say that, yeah, you did. I would say that most of your issues come from trying to take on too many of this functionality at the same time. That's really it.
Okay.
But I want you to focus on, when you do these functional requirements, focus on just the core issues and one issue at a time, right? Next thing is to really understand how this sharding works, because I didn't really agree that you had to split the file storage, because keep in mind, this actual file is just a URI, right? This URI can resolve to any file store anywhere. I don't agree with this pairing. That's why I don't agree with this pairing, because you might end up in a very weird situation where you might need like multiple. What happens if your file store grows and you need to have another, right? So in theory, you could have this all be like one file store or a network of file stores, and they don't have to be a correspondence to a single shard. You know, like shard A, B, C could all have items in file store because actual file is just a URI.
Okay.
So that's the
I guess like in hindsight, I could have just had like one file storage with like maybe 2 replicas, and then we could have caches or CDNs across for like accessing the actual file, and then we could just shard the photo metadata based on either user ID or like photo ID or like post ID, and then once we shard that, and then if we need to grab a file, we just hit the cache, and then that would grab it from the actual file storage.
Okay. The other thing to keep in mind is, well, we talked a little bit about keeping your data, right? Well, we want to talk about like file storage replication as well.
Yeah.
So that's something you might want to talk about. And then after that, then I would say once you've handled the photos, and I would say that at that point you've pretty much handled the photos, the next thing would be the newsfeed generation. So then you can then jump into that conversation. And I mean, I spent a lot of time guiding you through this, but then it's, you know, at the end of the day, it's just so that way we're working out like the issues of like handle one thing at a time. And I think, again, it just kind of mostly comes down to that. And then after that, like a lot of these, these mechanics, these cache mechanisms, and these questions that you ask are going to be pretty much the same. So I want you to focus on just that idea. Focus on just handling one thing at a time, and be able to really be able to like compare yourself to what the answer key is doing. So let's actually look at this. So let's actually go back here. So Instagram, blah, blah, blah. The functional requirements, you did a little bit more, but I kind of gave you this one. You pretty much nailed most of them, you know?
Yeah.
The newsfeed one was like, okay, well, I didn't know what direction that they were going in, but you know what? Okay, fine. You know, this one I would say, okay, it's okay if I didn't think about it, but but you did, I think about it, so it's okay. And you thought about a whole lot more. So, even if you did think about a whole lot more, it's about prioritizing that list down into the core components. So you did hit consistency and cap theorem. That's fine. Latency, yep. This is something I kind of remind you of. But it's like, how long are we willing to wait? Highly available, cap theorem. Highly reliable. So this is something that you need to be able to come up with as well. Design considerations, low latency, blah blah blah. And the capacity estimations. Again, think about like what the bandwidth is for your system and number of photos you're storing. It's like those are like very obvious questions. Those are like the I would say those are freebies, right? It's very obvious that your system should be able to handle a very large throughput, right?
Yeah.
1 million daily active users, blah blah blah. So this is like what you need to be able to do on your own very quickly. I would say, once you get good at this, these functional requirements and capacity estimation take you like 5-10 minutes.
Yeah. Currently, I think I'm pretty slow in the capacity estimation and constraints. I'm probably gonna spend and sit down with some just the numbers and do some random calculations.
It's not the calculations. It's actually the questions that you need to ask yourself. Like, and did I handle?
Yeah.
It's like, so for instance, if they put like 23 number photos per second, that and I don't have that, I'm gonna say next time I need to think about a way to represent the throughput in my system. That's really what I want you to focus on, not the numbers.
I mean, I could come up with like saying like, oh, they would do this this amount of photos per day or like per hour, and then we would have to translate it into like amount of storage we need, and that's where the calculation comes in. No?
Sure. Yeah, but what I'm saying is, don't worry about getting good at math. Like the numbers are essentially arbitrary.
Yeah. I know. They're not like make or break, but I need to get faster at them.
Yep.
Yeah.
It's more or less getting faster at asking the right questions. I want you to focus on asking the right questions.
Okay.
Does that make sense?
Yeah.
Again, because the numbers are arbitrary. Like, I don't care if you said 5 years. I don't care if you said 20 years. I just, like, they just chose 10 years, right? But the fact is that you need to be able to ask yourself how much total space is required. Okay. This is the core thing. Not the 10 years, okay? So, after that, database schema. Photo user, I would say I definitely mentioned like holding off on this because you didn't solve the core requirements of upload and view a photo. I mean, the follow is a gimme, it's a free, and I guess you could go for the low hanging fruit if you didn't intend on handling that immediately, but you kind of trapped yourself in doing it. It's like, oh, now that I have this schema here with the follow, I need to be able to do something with it. I think you kind of trapped yourself a little bit with that. So I would be very careful about this. Don't worry about this.
I initially didn't think about it. I was just like, oh yeah, just have users and followers. And I remember like, oh wait, like we have another requirement of followers. That's why I like added it in there.
Mm-hmm. Right, but I also felt like it kind of messed you up a little bit and kind of like you kind of debated yourself.
Yeah, it did. It kind of like distracted me away from like what I was doing initially.
So my suggestion to you is like just handle everything one at a time. And if this game is not immediately relevant, don't handle it. I mean, in the future, you will get better at that at compartmentalizing, and then you're just like, oh, it's a freebie. I'm just gonna do it and then forget about it.
Okay.
Yeah. That's basically what's gonna happen. And then here you can see like they went to a deeper discussion of like SQL versus NoSQL using Cassandra. Yeah. This is where like you might justify what kind of database you're gonna use. Since it's a key value store, Cassandra would probably work here. And this is like where you can start getting into those kind of discussions as well. Since you've read DDIA, you're actually a lot better to have this discussion of SQL versus NoSQL. Although personally, I'd call it schema versus schemaless just because it's a little bit more representative, but whatever.
Yeah.
Anyway, next thing, data size estimations. Personally, I would say this is okay to do, but you've already kind of done the terabyte, like the data estimations here. There's no need to do this again. I mean, you could do it, but personally, I think this is just a stupid exercise.
Okay.
Like, why do I need to like calculate the date of birth? What benefits is it going to give me? You know, because it's very obvious for us that the majority of the load is going to come from our photos. What's another 3 terabytes compared to 1,400 terabytes? So this is what I call like completely irrelevant. Next thing, component design. So you did the high level. You already did the high level, right? And you did fine on that. So that was okay. So you did that. Reliability and redundancy. This is the next part where like, okay, I need to start thinking about how to replicate my storage, right?
Yeah.
So this is like, oh, well, we put such a high emphasis on not losing our data. Well, we should probably mention that. Data sharding as well. So this is like, we kind of talked about this. I basically what you need to do is like for every single way that you can shard, like by user ID and photos, you need to be able to say the trade-offs, right? So I'm looking at this. It doesn't actually say what the correct answer is, but what if I'm looking at this and I look at what you did, I would basically ask myself, hey, what do I need to do in order to have all this? I need to have a discussion of the different ways I need to shard. That's it.
Yeah. Okay.
Yeah. So what are different issues with this partition schema? Hot users, latencies, etc. Schema of photo IDs, and then this is how we would generate the keys. blah blah blah. Basically, I would just compare myself and say, okay, how can I be asking myself the same question? I need a single point of failure, right? We never talked about
Yeah.
that, but yeah, we need to be able to identify, do I have a single point of failure here? Yeah, with the sharding. So this is like, once I see this, I would say, how do I try to prevent this in the future? And I was like, okay, I need to remember to ask myself this question, and then from there,
Okay.
I will know to work it out here. You know, it's
Yeah.
better, getting better at our process, not trying to memorize all this shit. And then we get to newsfeed generation as well. Different ways of sending newsfeed, blah blah blah. Pre-populating. I think there is a design newsfeed. We did that
Yeah,
exercise
there's a
actually.
yeah, we did that.
So in other words, you can probably do this all on your own. And you can oh yeah, design Facebook newsfeed. You can do this afterwards. But notice, like, up until this point, why did they only mention this here? Because we were focused on the photo shit before.
Yeah.
And then, okay, now the question is, okay, well, how do I create the newsfeed with sharded data? And then how do I do caching? Yeah. So basically,
Yeah.
you can see here, like, if you had gone further and filled out the newsfeed, you basically would have filled out and I think pretty much gotten most of the answers here. So you kind of see, like, how I was going back and forth and asked myself, hey, what did I miss? What am I going to get? Like, how do I, like, prevent myself from missing this question or this issue?
Yeah.
Did I think about this issue that they're talking about? Is it relevant? Is it not relevant? You know, like the fucking...
Yeah.
Extra calculations. It's not relevant because the fucking photos is obviously going to take so much more data than this 3 terabytes, right?
Yeah.
So I can make the argument that it's irrelevant. So what I want you to do is to be able to do the exact same thing we did for coding, and the instructions of the algorithms. Come up with a design like this on Excalidraw, and then do the comparison and annotate it. I want you to, like, say, hey, I could have done this. I forgot this. Da 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 da. And here's how I'm going to do it in the future.
Okay.
And I want to see. What's it called? We can do a replay on Thursday if you're up for it.
Yeah, we can certainly do it.
Yeah, and I want you to do a write up as well for a few of these. So yeah, remember to save the Excalidraw because I think they're kind of finicky with the workspace. But I want you to you can save the image here. Like, I think what's it called? There should be a export. So you export the image, save link or save image, and then put it in the Google Doc, and then I'll look over it.
Okay.
Yeah. So I want to give you the last 40 minutes that we have to do it on your own. Do you have any questions?
No, I think that's pretty helpful in terms of how to practice with it.
It's everything that we've been doing so far, exact same way, except for system design. That's it.
Yeah.
Okay. Then, if that's okay, keep me posted on your interview progress, and then I'll see you on Thursday.
Okay. Oh, wait. One last question.
Yeah.
In that case, if Uber does get back early, should I still try to schedule it on Thursday, or should I just try to schedule it next week instead?
Oh, good question. Shit. Let's play by ear. Message me.
Okay.
I'm gonna say
sounds good.
tentatively for now. Actually, on a scale of, I want you to take a shot at this tonight. And then message me before you're about to go to bed how you're feeling about all this, about the system design, and then based on that we can move forward.
Okay. Okay. I think if anything, like I think I'm, like, knowledge-wise, I think I'm good. It's just like I'm not fast enough, if that makes sense.
And that's where the execution comes in. That's why we need time to make sure you do this right. I'm afraid that if I put an artificial restraint, like, you have 3 days, you're just gonna rush through this. And we saw that happen like a few times. So I want to do this without the hang of a deadline on you. Like, worst comes to worst, we'll just push that to New Year, and then you have all the time in the world to make this right. I'd rather you get this right.
Okay. All right. I'll message you later then,
All right, sounds good.
before I go to bed. All right.
All right, talk to you later.
Bye. Bye.
All right, are there any other questions from the live stream? If not, yeah. Going once. Going twice. 3 times. All right. 4 times. All right. Well, you know what? I guess that's it. So I did cut the session short because I wanted him to have a lot of time to practice this, just in case we do end up with the Uber interview this week. But I suspect that based on what I saw today, I think we're going to need to push it out. And so we will be back here on Thursday with a session and then with him, and then hopefully we'll be able to do a replay of his system design. So with that, hope you guys enjoyed the session. If you guys want interview coaching yourself, you can book me for interview coaching at echantac.com. Join the Discord. All my socials are in the description. With that, have a good night, and I'll see you on Thursday.